In this presentation, we have to talk about physical significance of Klein-Cartan equation. For that, we have to start our journey with the Kg equation, del square psi minus 1 by c square dou square psi by dou t square minus m square c square by h cross square into psi equal to 0. Now take the complex conjugate of equation 1. Complex conjugate means psi should be replaced by psi star, so that we can get the equation of the form 2. Now pre-multiply all the terms of equation 1 by psi star, we can get the equation of form 3. Then multiply all the terms of equation 2 by psi, we can get the equation of form 4. Find out the value of 3 minus 4. Here psi star del square psi minus psi into del square psi star. Then take the second term, minus 1 by c square psi star dou square psi by dou t square, minus of this term, so minus into minus plus 1 by c square psi into dou square psi star by dou t square. These two terms are cancelled out, entire is equal to 0. We can get the equation of form 5. Just I have to give small modification to equation 5. These terms are present as such. Now I am going to take minus 1 by c square as a common term. Then the remaining terms are arranged as psi star dou square psi by dou t square minus of psi into dou square psi star by dou t square, entire is equal to 0. Now all the terms of equation 6 are multiplied by a negative sign. If I multiply the first term, this is changed as minus psi star del square psi, and the second term is changed as plus psi into del square psi star, so that I rearrange this term as psi into del square psi star minus psi star del square psi. Here if I put a negative sign, minus into minus plus 1 by c square psi star dou square psi by dou t square minus psi into dou square psi star by dou t square, entire is equal to 0. The equation 7 is obtained by the way of multiplying all the terms of equation 6 with a negative sign, nothing new to interpret. Then I have taken del outside here, del dot psi into del psi star minus psi star del psi. Here I have taken out dou by dou t outside, 1 by c square dou by dou t, then psi star dou psi by dou t minus psi into dou psi star by dou t, entire is equal to 0. Next multiply all the terms of equation 8 by IH cross by 2m. We can get IH cross by 2m del dot psi del psi star minus psi star del psi plus IH cross divided by 2m c square dou by dou t psi star dou psi by dou t minus psi into dou psi star by dou t, entire is equal to 0. Then equation 9a is obtained from 9, simply interchanging the terms. Just I have written the second term as a first term and the first term as a second term, nothing new to interpret. So we can get equation 9a. For our convenience, I have changed the terms. We know the continuity equation, dou p by dou t plus del dot j of r comma t equal to 0. This equation is available in electromagnetic theory also. If you compare equation 9a and 10, see that dou by dou t of certain things. Here dou p by dou t. So the p of r comma t equal to IH cross divided by 2mc square. Then the rest of the terms, psi star dou psi by dou t minus psi into dou psi star by dou t. Then here del dot certain terms. Here del dot j of r comma t. So j of r comma t is equal to IH cross divided by 2m psi del psi star minus psi star del psi. This is the value of j of r comma t. In the non-relativistic case, p of r comma t is called as position probability. Then j of r comma t is called as probability current density. The value of j of r comma t we have arrived in the relativistic case is exactly matched with the non-relativistic one. So here also j of r comma t is called as probability current density. But if you think about p of r comma t, the value of p of r comma t in the non-relativistic case is psi star psi is equal to absolute square of psi. The wave function may be real or complex, but the probability of finding the particle is always a real entity. If you think about this equation 11, if psi is real, p of r comma t equal to 0, because psi is real, dou psi by dou t equal to dou psi star by dou t. So p of r comma t equal to 0, but position probability cannot be equal to 0. It should have some value. So we cannot call this P of r comma t as a position probability in the relativistic case. Furthermore, if you take this equation P of r comma t, here 1 by 2 mc square is maintained as such, this psi star is present as such, this IH cross is taken inside the bracket, IH cross dou by dou t into psi. Just combine this IH cross with dou by dou t for our convenience. Then plus this minus sign is combined with this IH cross, plus the psi is present as such, minus IH cross dou by dou t into psi star. We know that IH cross dou by dou t is our energy operator, minus IH cross dou by dou t is our E star, complex conjugate of this energy operator. But if E is Hermitian, E star is equal to E. So this is E into psi star psi plus E into psi star psi. Psi star psi is absolute square of psi. So 2 times E into absolute square of psi. Then 2 get cancelled. The value of P of r comma t is E divided by mc square into absolute square of psi. Now we may ask a question, sir, E equal to mc square, so mc square get cancelled. So P of r comma t equal to absolute square of psi. Then in the relativistic case also we have had the same result of P of r comma t, but actually available in non-relativistic case. It is not correct because here E not equal to mc square, the value of E here is plus or minus root of c square h cross square k square plus m square c power 4. So E can have both positive and negative values. So we cannot call this P of r comma t as position probability. If you multiply this P of r comma t by the letter E, the charge, then E into P of r comma t is reinterpreted as electric charge density, because E is the charge of a particle. The charge may be having positive or negative values. Suppose E is positive, P of r comma t is positive. E is negative, P of r comma t is negative. But P of r comma t cannot be a negative quantity. So that P of r comma t is not called as position probability. E may have different values at different places. Therefore, instead of calling this P of r comma t as position probability and multiply P of r comma t by the term E, then E into P of r comma t is reinterpreted as electric charge density. This will lead to one conclusion, that is, Klein-Gordon equation is suitable for a system of particles having different signs of charges. That means both signs of charges. Suppose a system is having only one particle of given charge, the Kj equation is not suitable. If a system is having only one particle, that particle is electron, we cannot apply our Kj equation. If a system is having only one particle, that particle is positron, we cannot apply our Kj equation. But if a system is having particles with both signs of charges, that means positron and electron, at that moment we can apply our Kj equation. Therefore, in the case of relativistic quantum mechanics or relativistic Schrodinger equation or Klein-Gordon equation, P of r comma t cannot be called as position probability, but E into P of r comma t is reinterpreted as electric charge density. In the same way, E into J of r comma t is called as electric current density, because the value of E is not only positive, E can have both positive and negative values. The value of E is different at different places, so that Kj equation is suitable for a system of particles having different signs of charges. But the value of J of r comma t available in the case of relativistic quantum mechanics, that is in the case of Kj equation, is exactly matched with the value present in non-relativistic case. But the value of P of r comma t is not exactly matched. Therefore, we cannot call this P of r comma t as position probability in the case of Kj equation. But in the case of non-relativistic quantum mechanics, P of r comma t is called position probability, whose value is psi star psi, that is equal to absolute square of psi. Thank you.